Welcome to another ultralight airplane design video from the Ultralight Airplane Workshop. If you're new to this series, we're working on an ultralight airplane design where the ultralight falls underneath the U.S. Federal Aviation Regulations Part 103. And the name we're calling this ultralight airplane is UWS-4. We're using a book to help guide us in this design, and the book is by Dan Raymer and it's called Simplified Aircraft Design for Home Builders. Now in the last video, we finished up chapter 3 of his book where we worked on the aerodynamic design of the flying surface, or the aerodynamic surfaces of the ultralight. We're starting chapter 4 with this video. And in Dan's book, he calls stuffing some stuff in it. So I'm going to call this little mini series Stuffing. And the first part of this series is going to be working on the cabin design. Let's get started. Now, for those of you who have been following along faithfully, let's just quickly review what we did in the last video. In the last video, we worked on the length of the fuselage, although there really wasn't much to figure out or much to estimate. We already knew where the tail was going to be on our airplane, so all we had to do is hook up some booms to the wing for that. So the only remaining thing was to figure out the cabin, where we put the pilot, where we're going to put our engine, and how far out the nose is going to be. Now Dan does have an equation if you have absolutely no idea how long you want your fuselage to be. And we came up with 15.15 feet using Dan's equations. But when we went and measured our fuselage, at least the tip of the nose out to roughly the 25% mean aerodynamic chord of the tail, we came out with roughly 18 feet. And that was basically because of restrictions we placed on where to put the tail. We wanted the tail to be out of the propeller slipstream, so it had to be up a little bit high because it was an inverted V. And to keep the tail out of the wake of the wing when we're in a stall, we had to move it back quite a way. So that ended up making our equivalent fuselage length about 18 feet. That still isn't horrible. It's a little bit long, but it's not horrible. Now, if you've been following along in this series for a long time, you know what I'm just about ready to say. Although we've been using Dan's book, Simplified Aircraft Design for Home Builders, to guide us on this design, this series of videos is not a substitute for Dan's book. In other words, you should not use this video series as a basis of designing your own airplane. You really need to go get Dan's book and read it, because he covers a lot more than I cover in this video series. If I covered everything that Dan covered, these videos would be at least an hour long. They're long enough as it is, between 20 minutes and half an hour. Now, if you want to get Dan's book, there's a link down in the description that will take you to a web page that has Dan's book in there and some other books where you can click on that link and you can buy it at Amazon. And if you do use that link, the Ultralight Airplane Workshop will get a small cut of the sales. Now, let's get on to working on our cabin design. Now, for those of you who have Dan's book, we're going to go to page 42, and we're going to start talking about the standard man, or the 95 percentile man. What we're talking about here on the 95 percentile is that we want to make a cabin where at least 95%, in this case men, will fit within that cabin. The other 5% would be too large to fit comfortably. They might be able to shoehorn themselves into there, but it wouldn't be comfortable. Now, since in general women are usually a little bit smaller than men, it would be a little higher percentage of women that would be able to fit into the 95 percentile for men. Now, this tried and true method has been used for decades and decades. In fact, I did it when I was younger doing some airplane designs, where you're going to draw on a grid of paper the 95% man sizes for legs and arms, for torso, for feet, and then you're going to pin them together at the joints so that you can move those around. And then you'll put them into whatever position or pose you think your pilot will be in. And then you draw your airplane around that pilot. And that certainly works. But there's another way to do it. And that's to use OpenVSP with its human component. And I'll show you how to do that. Part of what's going to determine our cockpit design or cabin design is the position that the pilot is going to be in. There's not a whole lot of information on this on the internet. There's a little bit, and a lot of it is from other publications. For example, there's 2 of them in the EAA Sport Aviation magazine that I know about. One of them was brought to my attention by designer tier patron Keith, and he did that through our Discord server. And by the way, if you might be interested in being on the Discord server with us, check out the link down in the description of this video, for a link to the Patreon page of the Ultralight Airplane Workshop channel and take a look at not only being on the Discord server, but some other perks you can get by being a patron. So that link that Keith gave me was the May and June issues of Sport Aviation magazine from 1983, and the title was Human Factors. There's 1, 2, and there was a third one also. But just a quick summary of some of the pertinent information from there. They recommended that seat pan angle, so that's what you're sitting on, would be 6 to 8 degrees from horizontal, so the front would be tilted up a little bit, 6 to 8 degrees, and that the seat back angle would be 10 to 15 degrees from vertical. And if you want to go back a little bit farther from that, then you really need a headrest. Otherwise, your head will start getting some fatigue from having to bend forward a little bit. Now, another one that I found was also from Sport Aviation, and this is way back in 1963, and this was titled Cockpit Design Simplified. Now, on that one, they recommended going with a 90% size man instead of 95. And the reason for that is to just save a little bit of weight. You can make your cockpit a little bit smaller, which means you can make it a little bit lighter. So you're going to have to use your best judgment on what size percentile you want to use for your cockpit. Now on that, they went way farther back on their back angle. And in fact, they gave quite a few examples of various airplanes that ranged from 20.5 degrees to 27.5 degrees. And they recommended 24 degrees for the seat back angle. So that's a lot more than we got from this article. So as you can see from this, you're going to get different recommendations from different sources. So you're going to have to use some of your own judgment. We also got a little bit more information from this particular article. They gave a recommended hip angle, so that's the angle between your upper thighs and your back. They also gave a knee angle, that would be between your thighs and your calf. And then they recommended a good starting point for that for comfort. And then they gave a foot angle. Your foot should be at a normal resting position, roughly 9 degrees, when your rudder pedals are in the neutral position. Well, I have to admit, I liked this article quite a bit. It gave more recommendations, and it talked about some more comfort factors in there, where this article up here was more technical. It actually has a whole lot more information in it. So what I'd like to do next is to use OpenVSP and its human component and use some of the recommendations from this to try to figure out what pose or position I want for my pilot. And then we'll carry on some more cockpit design after that. Here we are in OpenVSP, and by the way, I'll put a link down in the description to OpenVSP. They just recently came out with a new version, and this is version 3.24.0. Now this is going to be a little bit like a tutorial. I want to show you a lot of the steps I'm going to use in using this human component. So let's get one added in here. Now this happens to be the design from OpenVSP that I used in the last video, and I happen to have a 170-pound human in this one, so let's show that. So this was the original pose I was thinking of using, and we're probably going to end up in just about the same pose again. And keep in mind that standard man for the FAA, the 170-pound man, we will only use when calculating the stall speed for an ultralight. You do not want to use that in your cockpit design because that's going to be too small. So I'd go with something a little bit bigger. So let's get rid of this for the moment, and let's start with a new man. So we come up here to the human component and we do an add. Now once we do that add, we get the configuration dialog for that person. So I'm going to change the name of it real quick. Now there's some tabs here that are specific to this human component. There's anthropomorphic and there's pose. Anthropomorphic is basically getting the size, and then pose is changing all the angles on the joints. Now there is no command to rotate this human figure over here in anthropomorphic or pose. You actually have to do this up here in your X form. So I'm going to actually rotate the whole thing in order to set the back angle. Let's go back real quick to what we were just looking at. So they recommend a 24-degree angle to kind of be in kind of the range of these existing airplanes. So let's try that. Let's go 24 degrees. So I'm going to go up here and I'm going to rotate about the y-axis. So the y-axis right now is coming in and out of the screen. I want to rotate about that axis. So we come down here, we go up to 24. So that's quite an angle. We're going to be setting back quite a bit with that, but I think that's okay to start with. Now keep in mind, the farther back you can rotate your pilot, let's go ahead and try something like a 45. If you can rotate back something like this, you can actually make a smaller frontal area on your fuselage. So if you're in something like a sailplane, you might want to be reclined like this in order to really reduce that frontal area. But you're also more likely to fall asleep on a really long ride. So let's not go quite that far. Let's go back up to the 24. Let's go to the anthropomorphic tab. Now you can select what kind of units you want. I'm going to go ahead and do feet just because I'm a little more comfortable with that. And you can select what kind of mass you want. So you could do kilograms if you wanted to. So you could combine feet with kilograms. But I'm going to go ahead and go with pounds mass. That's what LBM means. You can select the gender, male and female. I'm going to stick with male for now. Now these controls are grouped where if they're in a group, they actually are interdependent. So we could either set stature or we can set percent stature. So if I wanted to go up to around 6.5 feet, I could do that. Or I can do percent stature. So that would be setting something like that 95 percentile. So there would be 95 percentile, and that would be about 6 foot 2 inches. So you can see that these move together. So you can select one or the other. Well, I'm going to move down to the 90 percentile. It's because I'd like to have a slightly smaller fuselage. Now, for this group, we're actually setting the weight of your pilot. So you can do body mass index directly. You can do percent body mass index. So half basically means half the population would have more than this and half would have less than this. You can go by mass, which would be pounds. So right now, we're at 210 pounds. So I think I'll leave that there. It's not too bad. Next, you can do age, which kind of just changes the belly shape and the rear end shape of your pilot. So let's just play with that a little bit. Let's go ahead and leave it at about 30. You can also change the relative percentage of length of the lower body to length of the upper body. And that's what this sitting height is. So we can go all this way. You can see the torso got really long. Or we can go this way where the torso got short and the legs got longer. But I think we'll go back to about 50%. So that's it for the anthropomorphic tab. Let's go to the pose tab where we can start changing these angles. Now, unfortunately, there isn't a really great method for changing this head angle. Now, you can change the back angle a little bit, but that tends to change a lot of angle down here. Now, it helps move the head forward, which isn't too bad. I think we'll go with about 5 degrees there. You can also do a waist angle. I think we'll just leave it back at 0. Now you can start changing arms and legs. Now if you want your left and right side to be identical, you leave this enabled, so you have left and right symmetry. If you'd like to do left and right separately, then you turn this off. Now later we'll actually do the arms separately, but for now, since we're going to be dealing with legs, I'm going to leave them symmetrical. Now let's go back real quick and look at some of these angles we were talking about before. So the hip angle of 95 degrees, knee angle of, let's start with 120, and foot angle of 90. Now you're going to find the angles that are used over in OpenVSP aren't necessarily the same reference as we're talking about here. So we're going to have to adopt a little bit, but 95 degree hip angle. So that means the angle between the legs and your hips are just a little bit more open than they are closed for 95 degrees. So the hip angle is this one here. Now you'll notice at 90 degrees, it's kind of backwards of what we would want. So a little bit more open would be 85 instead of 95. So if we went on up to 95, you can see that it's a little bit more closed than open. So we actually have to come back to 85. Just kind of switch it around that 90 degree point. So that's pretty close. Knee angle is 120 degrees. Now, the way it was being measured in the article, this is actually be considered 180 degrees instead of 0 degrees like we have here. So what we really need to do is take 180, subtract 120, that would give us 60. So let's go to 60 degrees. So that would be the 120 that they were talking about in the article. And you can see here, angle is 0. Well, they're actually calling that 90 in the article. So it's a little bit confusing. But we're just going to leave it at 0, which is 90 in the article. That's perfectly fine. Okay, we now have the positions that they were talking about for the hip, knee, and ankle. Now I only want about 4 inches of crush depth below my pilot. And I'm guessing that's about here, which means my heels are a little bit lower than I would like. So I'm actually going to extend this angle out a little bit to where I think is probably about 4 inches. So let's go back this direction, about there. So that's about 10 degrees more. So that's about 130 degrees using the article's orientation. Now they said 80 to 140. So I'm not past what they consider to be a semi-comfortable position for the knees. So I think that's a good spot. The next thing we'll talk about is the over the nose or over the cowling vision angle, or the downward vision angle. It's called different things in different articles. Now the angle is going to be the difference between the horizontal line and how far down you can see over the nose of the airplane. So the angle between horizontal and whatever your angle of your eyes would be looking down. Now Dan recommends that angle be somewhere from 10 to 15 degrees. Now in this article that I was looking at, the Human Factors article from Sport Aviation, they say somewhere more than 11 degrees. Let's go put some of these lines in OpenVSP and see what that looks like. So here are some of those vision lines. This is the horizontal vision line. This is 11 degrees down from that horizontal vision line, and this one happens to be 20 degrees down. Now, I didn't mention it previously, but another thing that was talked about is transport aircraft frequently have this down vision line of 20 degrees. So if I can keep my nose of my airplane and my instrument panel below this 20 degree line, that sounds pretty darn good. So that's going to be my goal. Now I'm not able to angle this neck or head forward to where it should be. It should be a little bit more vertical. So I put these lines roughly where I think the eyeballs would be when you've got this head in the correct position. Next thing to tackle is the instrument panel. Let's look at what Dan says. Dan says that the bottom edge must be high enough that your legs aren't trapped in the cockpit when you're trying to get in and out. You don't want to be banging your legs against that instrument panel. And you don't want to have to kind of drag yourself out of the cockpit with your legs straight to get in and out. So you're going to have a little bit of height on the instrument panel for those legs to get in and out. And then he also mentions you have to have some area behind the instrument panel for your instruments to be. Now let's go back up here to this Human Factors article in Sport Aviation. This is in the May, June, and I think July issue of Sport Aviation, 1983. In that article, it's recommended that your instrument panel be about 28 inches or less from where your eye reference is. Then they say that the optimum eye rotation, in this case looking down from a horizontal line, should be about 30 degrees, and you don't really want to look down any more than 35 degrees. So let's go ahead and implement that in OpenVSP. Well, I've placed the instrument panel here between that 20 degree down line, and here's our eye reference point. So this is 20 degree down line from that reference. And remember, this is what we said our goal was, which is similar to what transport airplanes use. This is our 35 degree down line. So we don't want to have to look anywhere below this. So I think that'll probably give us a big enough instrument panel. And one thing that's really nice with this human figure in OpenVSP is I can extend this arm out here and see if I can touch that instrument panel, because that's pretty important to be able to touch it. So that's just about right at the arm length. Now, of course, I'm going to be a little bit smaller than this 90th percentile person. So I'll probably have to put about an inch of foam padding on the seat back in order to push me forward far enough that I can reach this instrument panel. But that's okay. I think that'll work good. And let me show you what I did for a really rough first estimate for this instrument panel. Let's roll around this direction. And for anyone that might be interested in trying to do this, I used a stack of 2 super ellipses for the outer edges of the panel, and then there's a point at the center of each of these ellipses to make the face of the panel. And then to get this flat bottom, I set the max W location to minus 1.0, which brought these corners down to the bottom edge of the ellipse. Now here you can see I set the distance to 2.16 feet. That's roughly 26 inches. 28 inches was the maximum that they suggested. So I think this will work out. So you don't have to stretch in order to reach the instrument panel. Next thing I want to consider is the control stick. Now Dan doesn't talk about the control stick in his cabin information, but guess what? Again, in this Human Factors article, they do talk about the control stick. I should mention that you can get just about all the back issues of the Experimental Aircraft Association Sporty Aviation magazines if you are a member of the EAA. And you can get those online by signing in to the EAA website. You can get those in PDF file format. And they're free. So the control stick, when it's in its neutral position, should be between your knees. Now that is true if your seat is not reclined very far. If it's reclined a little bit, you're probably going to have to move that stick back a little bit closer to you. If you're reclined something like 45 degrees, then you probably wouldn't be able to have a comfortable stick, and you may have to go to something like a yoke or a side stick. They recommend when you're pushing forward on the stick from the neutral position, the stick should move, the top of the stick should move forward about 5 inches. If you're pulling back to pitch up, the top of the stick should move back about 7 inches. And then also going to starboard and to port for the neutral position should also be about 7 inches. And then down where your knees are, your knees should be about 12 inches apart in order to get this much movement at the top of the stick. Now let's see what we can do about this in OpenVSP. So I put a stick in here. This stick right here, this vertical one, is the neutral position for the stick. Now this placement down here doesn't have to be exact. This could actually be a little far forward or a little farther aft. But for now, we're going to talk about it being vertical. And as you can see, I've manipulated this arm out to where I can touch the stick. Looking at the extension of this elbow, it looks like I may have a little bit of trouble moving it forward that 5 inches that we were just talking about for pitching down. I'll do a little experimenting with that. If that is an issue, I'm going to have to move the stick back an inch or two. Now here is the aft position. Now this distance from this top to this top is 0.633, which is roughly 7 inches. So that's how far I'd have to pull the stick back for its maximum deflection on the elevator. So that lets me know how far forward my seat can go. I don't want my seat to go any far forward than where this stick is right here. Or if I do really want to go farther forward, I don't want to, then I could actually cut out a little portion here in the middle of the seat, and then underneath the legs, it could come a little farther forward. I don't think that will be an issue, but we'll have to do a little experimenting with an actual cabin layout to find out. Now, one of the things that is a little bit of a drawback on this human form, let's take a look from the top. I'm not able to move these knees a foot apart without the heels also going way out. So I'm going to have to guess on my own just a little bit when I go to make my cabin. Let's put this pilot and the various parts here that we've worked on into the UWS-4 and start modifying the cabin to fit. So I moved what we were just looking at into the cabin of the UWS-4 as it was in the last video, unmodified. So as you can see, I'm going to have to make a few changes just to get this to fit. In order to keep the heel above the bottom, I'm going to have to raise the seat up another inch than I wanted to. Right now you can see this seat on here is 4 inches high. So I'm going to have to go up to about 5, maybe 5.5 inches deep for the seat. That's okay. I don't have the 6 inches here on top that I wanted, so I'm probably going to have to make this a little bit higher. This windshield is just a little bit too close. It's going to have to come out just a little bit more in order to make it over the top of this instrument panel. And I'm probably going to have to move this nose just a little bit farther forward in order to give my feet a little more room to move back and forth. Now I positioned the pilot so the leading edge of the wing is right between his navel and his chin. So that's a good starting point. Now once we start getting some CG values, we can start moving him as needed. And this seat is the recommended 8 degrees to start with that we talked about much earlier. I'm going to increase that angle just a little bit more so it'll be more comfortable, so I won't be trying to slide forward on the seat. But I wasn't too far off on my first guesses on this fuselage. I'm going to go ahead and do some of these changes without you having to suffer through me doing all kinds of tweaking on this, and let's see what we can come up with. Okay, looks like I've got this set up now. I had to make the fuselage a little bit taller, move the nose out in front just a little bit, raise this area just a little bit so it would cover the instrument panel, and I had to make the instrument panel just a little bit narrower. So let's see what we got here. I'll probably have to change the shape of the instrument panel just a little bit more. It looks like it could actually come out here a little bit farther if I reduce this curvature a little bit, make the radius a little bit larger. But for the moment, that's pretty good. Looks pretty close to what I want. Now, what's next for us to look at? Now let's talk about our door/canopy. Now Dan talks about the FAR 23 regulations for larger aircraft that really doesn't apply for us. So what I decided to do is go for visibility. So looking from the top, I've got the back of my canopy back behind my head. I could bring it forward just a little bit more, but I want to be able to turn my head to the right and see out over just past the trailing edge wingtip. And it looks like, for the way I've got it at the moment, I could even do better. I can probably see back here about where the boom's going to be fairly easily on the trailing edge. On the front of this canopy, I want to bring it down pretty close to where the instrument panel is. Right now I've got just a little bit in front of the instrument panel. That might be what I'll do. And then let's look at the side. I want to have it low enough that it's fairly easy to step over, and low enough that I can look over in this area and see down to the ground fairly easily. So I think I've accomplished that. Now there's still a whole lot more details we have to figure out, but we kind of have the overall placement of the various parts in the cabin now. We don't have nice numbers like we've calculated in previous videos, so we don't really have a nice summary to go over. So let's just talk about what's going to be next. So next video, we're going to do the next thing in Chapter 4 of Dan Raymer's book, and that's landing gear. So we got to figure out things like we're going to do a tail dragger configuration or a tricycle gear configuration, where we're going to put that main gear, and a few other details. I'm going to try to increase the pace of these videos just a little bit so we can get to building something a little bit sooner. So hopefully the next video will be out in about a week. So guys, until next time.